This is the Aftermarket Radio Network.
Welcome, everyone, to yet another episode of Diagnosing the Aftermarket A to Z. I'm Matt Fanslow. The Godfather is the I Ching. The Godfather is the sum of all wisdom. The Godfather is the answer to any question. What should I pack for my summer vacation? Leave the gun, take the cannoli. What day of the week is it? Monday, Tuesday, Thursday, Wednesday. That and more after a word from our sponsor, NAPA Autotech Training. Do you have a general service tech that you want to grow into your business, but you're lacking the path to get them there? Let NAPA Autotech's apprentice program pave the way. Go to napaautotech.com for more details. All right. I got really good questions in email. A lot of these questions, I like them. I keep them coming. They make me think. You're probably not the only one wondering with some of the questions on the more technical side, or really anything, I guess, honestly, management, stuff like that. So yeah, please keep them coming. Email is mattfonslowpodcast@gmail.com. Pretty much take on any question. And if I don't answer them on here, and even if I do, I usually try to respond. I've had results of that become pretty great conversations, and thank you very much for sending those. And without further ado, I will start with the first one, which it's a rough one. Matt, who do you try to emulate? Yeah. Wow. Well, let's see. My knee-jerk reaction to that was Hawkeye Pierce, Gregory House, and Perry Cox. All doctors, but all television, I guess, doctors. Hawkeye Pierce, obviously being from MASH, and Gregory House from House MD, and Perry Cox from Scrubs. For one, I find them hilarious, and they're all really good at their jobs. But more serious note, that's a rough question because I guess I try to take so much from so many. I don't think I could ever be anywhere near as good as a lot of these people are at what they do, but I try to emulate their thought processes, or I guess I will say strategies, and maybe to a degree behaviors. And I guess I'll elaborate. So the first response would have to be John Thornton. And if you listen to our episodes together, we had 2 in a row. He's very disciplined and I'm not. So that's an immediate almost contradiction. I wish I could be as disciplined as he is with his process. And not that his process is rigid, but that it is practiced and refined over and over to where even if it was rigid and he stuck to it, it is just extremely efficient. I tend not to operate that way, but what I definitely borrowed from him and many others who I've named before, including in that episode, the research, the resources, the studying, where to go. And from John, from Randy Burnclaw, Jim Kemper, who's also been a guest, Matthew Ragsdale, Harvey Chan, John Riegel. The list could probably go on. Those are the main heavy hitters for SAE documents. And I hate to say, I guess the SAE website, but there's materials on there beyond just the papers themselves. There's also collections. There's also books written by, I hate to say the manufacturers, honestly. It could be whoever is behind the design of a certain system. Would I tell you that reading a lot of that stuff, I know what they're all saying? No, but a lot of times there's little tidbits that I pick up on. Another resource was the Internal Combustion Engine Fundamentals book by John B. Heywood. It's quite literally the Bible of, maybe not auto repair, but how engines work and what's going on. If you do read a lot of SAE documents, you will find in the notes at the end, if you will, the references. That book, I think almost every freaking one I've ever read, paper, references that book. And there's many others. Another person that I learned to do that from is Jim Wilson, currently of Standard Motor Products. He also deep research, deep thinker. And I guess now that we're at it, so I try to emulate Jim Wilson from reading his posts on IATN and Diagnostic Network and on his website, flatradar.com, which is now scanshare.io. Just that thought process and inference and probabilities. I just took so much from that. And it's something I know I've talked about at length, broken record, repeat it, but just powerful. And Scott Manna, absolutely, the way he thinks about stuff, it can be so matter of fact sometimes. And I wish I kind of had that clarity. It could be just become a name drop fest. I'll have to call Tanner and have him come on. We'll have to do another name drop test because there's so many people that I just try to take bits and pieces from, or if I could, everything, and be more like that. I guess not to just stay focused on rattling off names, although it would be cool to rattle off names and compliments about them because they deserve it. They deserve recognition, and not just from me, but really from so many, whether we know it or not. We're better off because of their contributions. I don't know many people that they know Randy Burnklaw's name, Jim Kemper's name, Matthew Ragsdale's name, or maybe they've heard of these people, Jonathan Riegel, their contributions in training, or I guess on networks like IATN, like Diagnostic Network, have made all of us so much better at what we do. So much better with the sharing of that information and just how it's spread and is shared and it becomes knowledge or angles, I guess. This could be an episode all by itself, and forget the mailbags. Tanner and I are going to have to be on here rattling off names of people because that's what it would turn into. But yeah, I guess I thought this might be a shorter answer. The answer is a lot. All right. The next question is, I'm looking at exhaust gas analyzers. What should I be looking for? They're a lot of money, and if I'm going to spend it, I would like to spend it wisely. All right. That's a really good question. And I'm honestly really impressed because I think at one time it was a pretty common tool to have or desire, partly because of emissions testing, especially decentralized. So you saw more of them in shops or shops shopping for them. Not so much anymore. Even our resources for them has seemingly started to drop where we go to get them, although the prices haven't really dropped. And not that they're not worth it. It's an investment. Powerful, powerful, powerful tool. So what do you look for? To me, probably the primary thing is that it interfaces with something like a PC for sure, and maybe an Android device. The main reason being, I guess, really twofold. One is graphing. You want to be able to graph these gases. And if you could, if it'll do the conversion for you to graph lambda, just for ease on the eyes, so that you're not maybe trying to process all these gases, that you could just look at a number plotted over time for multiple reasons. Well, one is obviously you want to know, is it running rich, lean, stoic, whatever. Another reason is if it does the lambda calculation for you, it becomes a lot easier to use to kind of verify the accuracy of an air-fuel ratio sensor. So if the air-fuel ratio sensor is reading, or at least reporting, we'll say, depending on the car line. So this starts to get, I guess, fall apart a little bit. But a lot of them, we have PIDs that are giving us either lambda or equivalence ratio. It just makes it a little bit easier. So that's big. Portability. Most of them, I think, now that you would buy that I can think of off the cuff are portable. The heavy hitters that I can think of off the cuff are all portable or easily made portable. So that's a big deal because you want to be able to take these on test drives if you can, or not necessarily have it stuck in a bay. But really, you'd like to be able to take these on test drives and be able to record, graph the gases, graph lambda or air-fuel ratio, something of that nature. That makes them quite powerful tools. And then I guess the next thing, and this is maybe a little more on the luxury side of things, is fast sample times. All right. So you have transfer delays. Not only transfer delay from where it exits the cylinder to the tailpipe, but now with an exhaust gas analyzer from the tailpipe through the probe, through the hose to the bench itself, there's a transfer delay. And a lot of older systems, that transfer delay could be 20 seconds. I would say more modern ones and fairly big names, the transfer delays are like 5 seconds or less. That's really impressive to have that kind of a response time to sample from the tailpipe to a reading on your display within 4 or 5 seconds. That is really impressive and comes in very handy. So that's the big stuff. And yeah, you're looking at over $5,000 for one of these things, probably more like 7. So I think just make sure that it will interface with a PC, that it graphs the gases, or the software that you would use will graph the gases, that it will do some conversions for you, that it'll do the lambda calculation, that it'll do air fuel ratio. That's just taking some burden off you doing calculations yourself, whether it's to verify a sensor on the car or is this thing in fuel control or not. So that's a really good question. Hope you like the answer. It's what you were looking for.
NAPA Autotech training sessions are being conducted day and night in a town near you. This training caters to every level within your organization, be it a mechanical assistant, a mechanical specialist, a technology specialist, or a driver safety calibration specialist. Imagine a one-stop shop training partner in NAPA Autotech that will lead your team to a path to greatness. Autotech's entry-level Build-A-Tech classes convert the untapped potential of your new hires into money-making mechanical specialists. Autotech's higher-level tech update classes introduce specialists to the world of ever-changing technologies, which prevents your shop from getting technologically stagnant. Remember, if you're not moving forward, you're falling behind. And, turning to the front of the store, the Autotech Service Advisor class is an awesome way to hone your client advocate skill set, ultimately benefiting the customer through an improved vehicle repair experience. But it doesn't stop there. Imagine an electric vehicle class that takes your specialist well past the mundane, yet necessary safety topics. Well, it's here. Autotech's EV Ready training is a week-long curriculum that takes participants through a hands-on experience involving hybrids and electric vehicles. The session kicks off with the use of PPE and proper tooling while touching on required OSHA regulations. Then, the students dive into the lab vehicles to gain knowledge of the common high-voltage components on EV and hybrid vehicles and their function. Attendees will be taken on a path exposing them to different electric vehicle manufacturers to compare component form and location. Additionally, information about Level 1 and Level 2 charging systems will be included, along with a quick look at DC to DC charging. The operation and maintenance of subsystems are explored, including the different modes of Tesla operations, and so much more. So what are you waiting for? Commit to taking your business to the next level with NAPA Autotech training.
Okay, and this is from a student. They're currently going to college. They had heard it said that using, so I'm paraphrasing this question. They're being taught in class to use a thermal imager or infrared temperature to test inlet and outlet gases of a catalytic converter. But they've heard on podcasts, specifically the one I did with Jim Kemper and in a few others, where this is an inaccurate test. What is the truth? Well, the truth is we had the expert on this podcast with Jim Kemper. It's episode 29, and I think we touch a little bit upon it. We could talk about catalytic converter testing. In a way, it would take a long time to arrive at one conclusion. Let the PCM do it. Make sure the PCM is getting what it needs, that what it's using is accurate. So make sure that it's in fuel control. Make sure that the sensors, air fuel ratio or oxygen sensors, lambda sensors are functioning properly. There's no exhaust leaks. There's no firmware updates. And let the PCM do it. Where I think the argument for looking at inlet outlet gases is also the same argument against using pre and post CAT O2 sensors and comparing switch rates. The algorithms used by the PCM to determine the oxygen storage capacity of the CAT or infer its conversion efficiency is far more complex than looking at switch rate. Where I'm going with that is if we're looking at inlet temperature versus outlet temperature or switch rate on a vehicle, and we're saying that the outlet temperature should be higher by whatever amount than the inlet, that if you have a car in there and you're just testing every car that comes in, you're testing the inlet versus the outlet temperature, and you get one that's quote unquote bad, but there's no check engine light, are you really going to throw a CAT at this car? And if you're checking it with a check engine light and presumably a P04 2430, and now you're testing it and it fails, so what? But what if you test it, it's got the check engine light, and you test it and it passes your temperature test? Are you not going to verify it's in fuel control, check for exhaust leaks, check for firmware updates, and then not put a CAT in it because it passed your temperature test? Probably not. So it renders the temperature test irrelevant. And if it was that good of a test, we would have thermocouples or pyrometers of some sort in the exhaust. Forget oxygen sensors, forget the algorithms used to calculate, usually it's oxygen storage capacity, to determine the efficiency of the CAT. So that's how I would just put to rest anything about using temperature or switch rate for us to diagnose a bad CAT. The algorithm in the PCM is far more complex, far more, and we'll just say, go back to, it's far more complex than what we're going to do with our scan tools or even scopes when talking about switch rate or comparing pre and post CATs. So yeah, that's how I would put that argument to bed. It's a good argument and there's nothing wrong with thinking about this stuff. But, you know, if you've got a check engine light on for CAT efficiency concern, DTC, and you verify what you need to verify, it doesn't really matter if it passes or fails your inlet outlet temperature. And if it doesn't have a DTC and it fails inlet outlet, are you really going to be bolting on a catalytic converter? It's not reasonable. All right. And maybe the last question for this episode. I'm finally getting into ADAS calibrations and I am starting to really have struggles with static calibrations of windshield cameras. I'm not sure what I'm doing wrong. Do you have any advice? I guess without being there, it's hard to tell. My knee-jerk reaction is, one, where's the target being set up and what's behind the target? Is there anything behind the target that's light colored and dark colored, almost mimicking another target behind the target? So yeah, make sure there's really not much behind your targets. And if you have to, maybe start thinking about putting up some sort of a shade or curtain, anything to kind of block that. If not, then I think the other big thing is, under what conditions are we talking about calibrating these? Is this windshield replacement? And if it's always windshield replacement, then are you using OE glass or aftermarket glass? I would never lie to you and say that I haven't run into factory or OE glass that has caused failed calibrations. It's just the frequency of that is so much less than aftermarket. It almost bears no reason to bring it up. Aftermarket glass, we still have issues. Now, some high volume vehicles, it doesn't seem to be quite the same issue. But if you're going to have a calibration fail and it's the glass's fault, the windshield glass fault, almost every time it's aftermarket glass. The other thing then is what I think, if those things aren't, you've kind of eliminated those as possibilities, is lighting. What is the lighting in the shop? And do you have really, really well lit area? Because that could be the problem. It's too well lit. You may have to either be able to kind of dim the lights. You may have to look into diffusers. So diffusers are something photographers would know a lot about, where you kind of, I guess, reduces the intensity and thus the glare. We want a bright area, just not too bright. We don't really want that brilliant, high intensity light. LEDs are pretty bad about this. If you have nice new LED lights, they're great to work with. They cause a lot of glare and can be very problematic for calibrations of cameras. So that's what I would be looking at. You can try getting like some shipping blankets, preferably fairly soft ones. You can try throwing them on the hood, on top of the hood, also on the dash itself. That may help. But if you just have really bright lights, you might have to figure out how to diffuse it a little bit, or be able to dim them or shut ones that are near or right above the vehicle, shut them off. Or also the ones near target. So if you're looking at your target through the windshield, can you see like the reflections of the light where it's basically washing out the dark parts of the target, right? So if you have just kind of a checkerboard target, are the black checker, are they actually black? Or because of the reflections of the light, the glare of the lights, are they really white? Those are the main things I would think of that would be causing issues. Outside of that, gosh, I would think it would have, the other things I'm thinking of would maybe affect all calibrations, but you have to take into consideration like floor slope, and then what information or process are you following to set up the target? I don't know what equipment you're using, but if you follow the equipment procedure, does it match the OEs? And when I say that, I mean, they maybe kind of find where to set the target differently, but either way, it should be in exactly the same place. So maybe you want to set up that target using factory service information in that procedure, and that may take longer. You may require a lot more drawing with chalk on the floor or tape or strings, running strings, but verify that the target is where it needs to be. And you have to verify that against factory service information. So, Brian Pollock hit strikes again, RTFM. That would be my advice. That doesn't work out, and I'll send you an email anyways, but email me back and see if any of that works. Yeah, so I guess I will call it on this episode. Yeah, on that huge disappointment, we'll end. Thank you to NAPA Autotech Training for sponsoring. Thank you to the Aftermarket Radio Network for making this possible. Thank you all for listening. And until next time, take care.
You've been listening to Matt Fanslow, diagnosing the aftermarket A to Z on the Aftermarket Radio Network. Follow Matt on your favorite listening app. He's very interested in what you have to say. Let him know what you'd like him to cover and come on the show. Matt is all for advancing the aftermarket. Find Matt Fanslow on social media and connect or on aftermarketradionetwork.com.